Okay, good afternoon, everyone. How are you doing today? Just want to welcome you to our live session today. Today is going to be unique. We're going to have some 7th or 8th grade all the way through. We're looking at some Pre-Algebra 2, and I'm going to just help you with some questions. I've come up with some questions that I have seen that students have struggled with, and I just want to give us an opportunity to solve them together. There'll also be some puzzles. I think after every 2 or 3 questions, there's going to be a puzzle just to get us get our minds working outside of the math world. And so I'm looking forward to the time with you this afternoon, and I hope you're excited to join us as well. Always remember, in our sessions, you can ask any questions you want. You can ask me to repeat any steps that does not seem that clear to you. And so let's just have a good time. Let's relax, have a good time, and enjoy the ride. If you're joining us for the first time, please go ahead and subscribe. You're welcome. Thank you for joining us. Thank you for spending some of your afternoon with us. We know that there could be many other things that you could do, but the fact that you've chosen to spend it with us, we appreciate it, and we're really grateful for that. We'll wait for a few more minutes, maybe a minute or so, for more people to come in, and then we can get started with some of our questions. So today there'll be lots of algebra, and some of the topics that I'll be covering today are very applicable to your SAT and your ACT and any other standardized or test prep exams that you want to do. Okay, let's get started with our questions. So with this question, we're looking for the greatest common factor of algebraic expressions. In today's session, I did not put any grades because I want you to realize that this applies to several grades. This applies anywhere from about 8th grade to 12th grade. So we're going to look for the greatest common factor of these algebraic terms. I'm going to give you some time to try to answer the question, and then after that I will show you exactly how to go about it. And if you have any questions, you can ask. While you're solving, just how are you guys doing? How are you enjoying your summer? Any summer plans that you're excited about? Or are you just home studying, playing? I know you may be getting some time for the Xbox or the PS4 or whatever else you like to do. Maybe you like to read. So what's your summer plan like? Okay, looks like we haven't some of us are not ready to respond, or maybe you're still thinking through it. Is anyone trying it and finding it difficult? Just let me know. I'll go ahead and show you the different ways to look at them. Anyone trying it and not sure what to do? Or anyone lost with this question? I have no clue. Okay, so I see someone is not sure what to do. So thank you, Anastasia, for your response, and thank you for participating. All right, so let me show you what to do when you have a question like this. I'm a big fan of prime factor trees. Very big fan of it. So I'm going to create prime factor trees for each of these numbers. We're going to start with 45, and we're going to create a prime factor tree, which means that we're going to look at a way to express 45 as a product of all its prime factors. So let's go ahead and divide this by 3, and we get 15. We're going to divide this also by 3, and we have 5. So 45, p to the third power, q to the second power is going to be 3 multiplied by 3 multiplied by 5, and then we'll break up p cubed into the product of its parts. So that is 3p's, 3p multiplied by p multiplied by p, and then q multiplied by q. And then we're now going to break down 75. So 75, we're going to decompose it into its prime factors. So we have 3 here, and then 25, and then 25 is 5 multiplied by 5. And so we have 75 p squared q cubed. This is going to be 3 multiplied by 5 multiplied by 5. And then we have p squared p multiplied by p, and then q to the third power means that they're going to be 3 q's. Okay, now we have 120, so 120. So we divide, it's an even number, so we divide by 2, we have 60. Another even number, divide by 2, we have 30. Still an even number, 2, we have 15. And then we break this up to 3 multiplied by 5. So now we have 120 PQ. 120 PQ is going to be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. And then we have P and Q. So multiplied by P and multiplied by Q. Now to get the greatest common factor of any terms, here we have 3 different terms. We're going to look for the factors that show up in each of these expressions. So I'm going to pick a different color here. So let's look at 3. Do we have a 3 here? We do have a 3, and a 3. So your greatest common factor is going to be 3 multiplied by something. Let's see what's next. Let's look at 3 again. We have, so if you use this, as you're learning this, once you pick the factor, you can just cross it out. So that way you know not to use it again. So now you have 3 here, 5. So there's no other 3, so we skip that. Let's look for 5. We have 5 here, we have 5 here, and then we have 5 here. So let's cross 5 out because we know we're going to use that. And so that is going to give us multiplied by 5. And then let's go to the terms. Well, let's also come here. We have 2 here. There's no 2, and there's 2. 2 does not appear anywhere else, so we can just ignore it. So we can see here that the only things that appear for all 3 terms is 3 and then 5. And then we keep our multiplication. The next thing we're going to look for is P. Let's look for P. We have 1 here, 1 here, 1 here. Okay, that is good. We can pick that and then cross it off. And we will not forget to have it right here, P. And then let's look for, are there any other p's? There's a p here, there's a p here, but there's no other p. So what you want to always remember is that you're going to pay attention to how many times, the number of times it appears for all three of them is what you're going to focus on. So p appears once, only appears once for this number, so you're only going to have one of the p's. Now let's look at q. Q appears here twice, it appears here 3 times, appears here once. So there's only going to be one Q, one right here. So let's go back to our color. We have a Q here, a Q here, and a Q here. Let's cross them out. And then we can see that there are no other common terms for all the 3 different expressions. So now we're going to multiply, and that's going to give us our greatest common factor. So we have 3 multiplied by 5, that is 15. And then P multiplied by Q is PQ. So this is going to be your greatest common factor of these 3 terms. Are there any questions? Let's run through it one more time. When you have when you have any set of terms, you want to first express each of the terms as a product of its prime factors. And then you want to look for the prime factors that appear for every single term, and that's what you're going to have for your greatest common factor. That's simply all you have to do for greatest common factor. Are there any questions? Would you like me to do another example? Let me know if there are questions or if you want another example. Otherwise, we can move on to the next question. Okay, let's move on to the next one. So we have x squared plus 8x minus 48 equal to 0. We want to solve for x. Let's solve x squared plus 8x minus 48. This question is actually going to be available for you from Algebra 1. You're going to learn this in Algebra 1, and you will use it in geometry. You use it in Algebra 2, and then anything else you do in math, from then on, you will encounter quadratic equations. So we're going to, there are lots of different ways you can solve this. I'm going to use the quadratic formula. It's the easiest way to do it. So I'll give you some time to get the values of x. What are the values of x that make this equation correct or make this equation true? Middle schoolers and high schoolers, where are you? No participation today? Okay, so I'll give you a few more moments on this, and then I'll show you exactly what to do. Let me give you a hint so that you can have something to work with. The quadratic formula, I'm going to use the quadratic formula. The quadratic formula is expressed this way: x equal to, okay, Esther, thank you for your response. Take a look at it one more time. You're really close on the other one. So you got negative 12 and 3. Take a look at your expression again, your equation again, and tell me what you come up with. So x equal to negative b plus or minus the square root of b squared minus 4ac over 2a. You are headed down the right path. I want you to just look at your computation, look at your calculation, and see if you can spot an error. I'll give you some more time. And for those that are new here, please go ahead and subscribe so that whenever we have these sessions coming up, we will be able to let you know. You'll get a notification that this is about to happen. On Tuesdays, we have puzzle time, and we also have some math topics for the younger grades. So we're looking at most elementary all the way to about 7th grade. And then on Thursdays, we're doing more informational sessions. And sometimes we do SAT. Today, I just decided to do some math topics that I've observed that students tend to struggle with as we have begun our summer program. So that's why you have this type of questions. All right. Esther, that's a good job. Good job on that. I'm glad you're able to find the error. So let's go ahead and walk through this together. So you're going to start with your standard quadratic equation, which is ax squared plus bx plus c equal to 0. And once you have to remember this because it helps you identify all the values you need to plug into this quadratic formula. So we're going to find out the values of a, b, and c. And so to do that, you're going to compare this equation here with the equation you were given. So here a is equal to 1. Always remember in algebra, if you don't have any value to the left of a variable, assume that it is 1. You are safe to say that it is 1. And so a is equal to 1, b is equal to 8, and then c is equal to negative 48. Now that we have these values, guess what? We can now substitute them into this equation that we have up here. So that's going to give us x equal to negative b, so that's going to be negative 8 plus or minus the square root of b squared, that's going to be 8 squared minus 4 multiplied by a is 1, and then c is negative 48. And we divide by 2 multiplied by a, so that's 2 multiplied by 1. All right, so that's going to give us negative 8 plus or minus square root of 8 squared is 64 minus 4 multiplied by, so you have negative 4 here multiplied by negative 48. Let's do something quick here. 48 multiplied by 4. So this is 2, bring 3 up here. So we have 192. So because you have negative, this becomes plus 192, and we divide this by 2. So we're going to simply have, let's add 64 here. This is 6, this is 5, this is 2. Okay, so we have negative 8 plus or minus the square root of 256 divided by 2. And if you work this out, you will find out that the square root of 256 is 16. So negative 8 plus or minus 16 divided by 2. Now we need to find out the values of x. So x is going to, because you have this plus minus here, it means that x is going to have, you're going to get x in 2 ways. You're going to have x equal to negative 8 plus 16 divided by 2. You're also going to get it by having x equal to negative 8 minus 16 divided by 2. This simply means that you could potentially have 2 different answers. So this is going to give us negative 8 plus 16. That's going to be, remember, when you have when the signs are different, you're going to subtract the numbers. So we subtract, we have 8. Let's inherit the sign on the bigger number, which is a positive, and then we divide by 2. So x equal to 4. And then in this case, whenever you have the same signs, what you're going to do is add the numbers together. 16 plus 8 is 24. And so it's 24. Then we inherit the sign of the original numbers, which is negative, and we divide by 2. So x here is negative 12. So now your answer is going to be x equal to negative 12, 4. You can also write it this way, x equal to 4, negative 12. Some teachers prefer you start with the smaller number and end with the larger number. It doesn't make a lot of difference to me, but depends on what your teacher wants or what the exam you're looking for requires. These are your 2 answers to the question. Are there any questions on this topic? So remember, there are 3 ways to actually do this same question. We can use the factoring method. We can also use completing the square to do this. But I find that for students, the quadratic formula makes it a lot easier to get your answer. So if you have any questions, let me know. I'll be glad to get through those questions with you. And I'll wait for a few moments to see if anybody has a question. If you want us to do another example like this, let me know, and then we can do one more example. Otherwise, we can go to the next one. The next one is going to be a puzzle. Like I said earlier, I'm going to try to give 2 math problems and a puzzle until the end of the session. Another example. Okay, thank you. Thank you for asking for that. So let's go ahead and try another example. So this example, we're going to say 3x squared plus 8x let's see what minus 33 minus 11, sorry, minus 11 is equal to 0. Okay, yes. 3x squared plus 8x minus 11 equal to 0. And we're always going to start off by identifying a quadratic formula. So x equal to negative b plus or minus the square root of b squared minus 4ac. All of this divided by 2a. And the next step after that is to identify or to write out your standard quadratic equation. So you will notice that everything that I'm going to show you in steps, because I want you to be able to develop the steps that you can repeat so many times, because repetition leads to retention. If you repeat it enough, it would automatically become a part of the way you do your math. So let's go ahead with our standard quadratic equation. Ax squared plus bx plus c equal to 0. So now we're going to get the values of a, b, and c. So as I'm going through this, if there's any part of it that you don't understand, or you feel like I lost you, please let me know. I'll keep looking at the chat to make sure that I can bring you along. So now that we have this, we have a equal to, you see now, a equal to 3. Because we have a number, we're going to use that. Remember, if we don't have a number, just use 1. A equal to 3, b equal to 8, and then c is equal to negative 11. Now that we have all of this, we can substitute into the equation. So we have x equal to negative b, so that is negative 8 plus or minus the square root of b squared, which is 8 squared minus 4, a is 3, c is negative 11, and all of this divided by 2a, so that is 2 multiplied by 3. So now we have negative 8 plus or minus the square root of 64, and then we have negative 4 multiplied by 3 multiplied by negative 11. So 4 multiplied by 3 is 12, 12 multiplied by 11 is 132. We have a negative here and a negative here, so it becomes a positive 132 divided by 2 multiplied by 3 gives you 6. So now we have negative 8 plus or minus the square root of, let's go ahead and find 132, and we're adding 64 to that, and we should have 196 plus 196 divided by 6. So now let's go ahead and simplify all of this. We have negative 8 plus or minus 14 divided by 6. Now that we've got to this point, we know to say that x is going to be equal to x is going to be equal to negative 8, not 18, negative 8 so we have negative 8 plus 14 divided by 6. The other solution we're going to have x equal to negative 8 minus 14 divided by 6. So now let's go ahead and find all our values of x. Negative 8 plus 14, the signs are different, so subtract the numbers. 14 minus 8 is 6. The sign on the larger number is positive, so we keep that, divided by 6, which is going to give us 1. And here the signs are the same, so we just add the numbers and keep the sign. 8 plus 14 is 22. We keep the negative sign, divided by 6. And now we can simplify this, divide both sides, both numerator and denominator by 2. We have negative 11 over 3. So therefore, we can simply say x equal to negative 11 over 3. We put a comma here and 1. Or x equal to 1 negative 11 over 3. They're both the same thing. Is this clearer now? Adeze, is this clearer? I hope this makes more sense to you. If you would like some more examples, you can post the videos that we have on our channel that addresses this specific topic, and then that should be helpful. Okay, all right, good job. Thank you. Thanks for your response. Okay, so now let's do a first puzzle for the day. So based on this, which of these glasses will get full first? This is open to everyone, even if we have younger students or lower grades. This will be fine for you as well. So which of these glasses, 1, 2, 3, 4, 5, 6, or 7, which one will get full first? 7. Okay, that's interesting. Let's see what if anyone else has a different glass that gets full first. I see 7, 7, 4, 7. Well, everybody's looking at 7. That's very interesting. So glass number 4. Okay. Let me just highlight a few things and see 7 or 5. Let's see 5. Let me highlight a few things for you so that to see if that would change your mind on your answer. Let me do this right here. Can you see here? There's a blockage right there. It's never going to flow that way. And here also, there's a blockage. It will never flow that way. So let's see if how that changes your answer. 6. Look at this right here. There's a blockage right here. It's never going to go into that glass. I see. Let me see 4. Okay. I mean, 4 is logical. 4 is well, 4. I can see your reasoning for 4. Let's see if anybody else has a different answer. It is tricky. It's to make you think, to be able to, so you can look for different things. And so when you're flowing through the glass, you have to make sure, even though it looks like there's a hose, but if the hose is blocked, nothing is going to flow. That's what this is actually testing, that you can spot that Glass number 1. Wow, glass number 1. Okay, I see number 3. But look at number 1. Before number 1, think about this path. Before number 1 can get full, number 3 has to get full first. Number 2 also has to get full first. So number 1 cannot be the first to get full. Let's look at 3. What about 4? Why would 3 not get full? Why would 4 get full before 3? And why do you think 3 would get full before 4? Okay, I see 3. Everyone is okay. Everyone settles for 3. All right, that's good. That's good. And let me explain it to you. 3 is the correct answer. Here's what happens when you're filling a glass. So we're going to start from 1. Let me get a different color that would show. Okay, so we're starting from 1, but when you're filling the glass, guess what? As it's actually going to go from the hose at the bottom is going to be able to transfer the milk first before the hose at the top, because you're filling it in. It's going to have to fill up this way. So before it gets to this point, this cup most likely is already full. So glass number 3 is going to get full first. How was that? Tricky? Easy? I could have seen it, but I'm not sure what I was thinking. Lots of different ways to look at this. All right. So let's go to the next thing. I want to remind you again that we still have our summer sessions going on. Actually, tomorrow we're going to kick off our SAT ACT program. Tomorrow is going to be twice a week, but tomorrow we're going to have our first 2-hour session. But if you're in any grade from elementary all the way through to right now, we have students from, I believe, grade 2 all the way to grade 11. And so if you would like to join any of the sessions, let your parents know. It's very interesting because we're looking at your curriculum, and we're also looking at the assessment tests and seeing where you're struggling right now and try to address those first before we move into more advanced topics. I'm sure those that are already in the program can attest to the fact that we're really trying to cover topics that will be beneficial to you. So don't forget, tomorrow SAT ACT program begins. We're going to be going for 15 weeks. It's going to be every week for the next 15 weeks. And it should be interesting. It's going to be through Zoom. So if you're interested, those are the ways to contact us. Look forward to hearing from you. And I'm actually looking forward to tomorrow's class. It was hard. Yeah. I can see why you think it was hard. Yeah, I can see that. But I hope it makes sense. So at least I hope you're able to see the different ways to look at problems. You have to look at problems from you have to look at the whole problem and not just little bits of it. You have to look at the whole problem. That way you can figure out exactly how to go about it. Okay, another set of quadratics, and this is actually more of an Algebra 2 question, but you need your knowledge from Algebra 1 to answer it. Let me give you a hint on this. This is going to be a plus b squared is going to be a squared plus 2ab plus b squared, and then a minus b squared is going to be a squared minus 2ab plus b squared. So now if you find out what a and b are, if you find out the values of a and b, you can easily realize that the middle term is the product of a and b multiplied by 2. You're going to need these two equations to solve this question. You're going to need these two equations to solve this problem, and you're going to end up simplifying. Anybody not sure what to do? Anybody not sure what to do today with this question? I'll give you some more time to think through it. You fill in the formula. Okay. Let's see. Well, this one there's no equal to, so you can't use that formula. So you can't use that formula. So look at this right here. So look at all the equations here. Let's do the first one. So let's look at this is x. We have 6x and we have 9. So in this case, let's say this is going to be x, and then this is going to be 3 squared. This is x squared, this is 3 squared. So we're going to pick x multiplied by 3. That is 3x multiplied by 2. That's going to be 6x. So that top one is going to look like this. X squared plus 6x plus 9 is going to be x plus 3 squared. And then let's look at the bottom one, and I'm going to see if you guys can simplify it once we're done. The bottom one is x squared minus 10x plus 25. So here you're going to have x, and then you're going to have 5. And so you have, it could be positive or negative, but because I know that this is a negative number, I'm going to use negative 5 here. So negative 5. So x multiplied by negative 5 is negative 5x multiplied by 2. That is going to give you negative 10x. So you're going to have x minus 5 squared. So now our expression is going to look like this. X plus 3 squared multiplied by x minus 5 divided by x minus 5 squared multiplied by x plus 3. Let's see what you come up with. So I've gotten you halfway through. The rest of it is just simple division. Anybody have an idea what to do? So I know some of the questions here. Are you allowed to add a variable and a constant together? No, you can't add them. You can multiply them together, but you can't add them together. But you guys are doing so well. I know some of these, 3x squared minus 2x minus 15. I think you're on the right path. But you don't actually, I don't actually want you to simplify it. I just want you to get to. So let me show you what I'm looking for. So you have x plus 3 squared is the same as x plus 3 multiplied by x plus 3. And then we have x minus 5. This is actually algebra 1. Some of this, it may look like algebra 2, but it's algebra 1. Everything you need to answer this, you learn in algebra 1. So this is going to be x minus 5 multiplied by x minus 5 multiplied by x plus 3. So what you have to remember is when you're dividing, you can look for common terms. So here you have x plus 3, x plus 3, x minus 5. Let's see if we have another x plus 3. We have 1 here. We can cancel this out. And then Is there another x plus 3? No. What about x minus 5? We have 1 here, and then we have 1 here. So you end up having x plus 3 divided by x minus 5 as your answer. So that's what I was really testing. I wanted to test if you could divide algebraic terms by each other. So this is what you would do. Whenever you have a question like this, you'll first factor each of the quadratic terms, rather each of the quadratic expressions, and then see if you can find any common factors. When you have common factors, you divide them through, and then whatever is left is going to be the solution to your problem. Yeah, this is algebra 1. So let's try something else that I know there are some students going to algebra 1. So I'm going to give you a problem now that should be down. It should be something that you can easily do, or that you at least can attempt. All right. Okay, I will try to explain that. I think because you have not taken any of the factoring, you have not done factoring to that level. You may not get it yet, but I can send you something that would help you. It'll take me a while to explain it. So this should be one that anyone can attempt. Which of the following is a rational number? Which of the following is a rational number? Remember, a rational number is any number you can express as a fraction. Does everyone want me to explain the previous example again? I know after we get through this, does anyone want me to go over that one again? I can try to simplify it in a short time. If you want me to go through that again, I will go through it. So I'm going to show you some things here. Let me give you a hint on this question. We're looking for which of this is a rational number. Whenever you have this type of expression, if I have the square root of a over b, don't forget that that also can be done as the square root of a divided by the square root of b. And if I have the square root of a divided by the square root of b, I can always write it as the square root of a divided by b. We're looking for a rational number. Remember, a rational number is any... Okay, I'll explain it after this. A rational number is a number that you can express as a over b, where a and b are integers. A and b have to be integers. They could be positive, they could be negative. So what you would do, I see everyone says negative 4. Actually, what I'm going to do is I'm going to see if I can pull up a calculator. And I'll show you that that number, this square root of negative 4, does not even give you an answer on the calculator. It's going to give you an error. So that's not a rational number. Every rational number you can find on the number line. So you have to pay attention to that. So let's try to simplify each of these ones, and then you will see how to come up with your answer. So the square root of negative square root of 28. So we want to find the square root of 28. So let's create our factor trees. 28, we have 2 and 14, and 14 we have 2 and 7. Okay, so we can see that there's only one pair of 2's here, and there's a single 7. So this is going to give us negative 2, square root of 7, negative 2 square root of 7. So this is not a rational number because you can't really express this as a over b. Now let's look for the next one. It is the square root of 49 over 81. So that's going to give us the square root of 49 divided by the square root of 81. What is the square root of 49? That is 7. The square root of 81 is 9. You can see that's a fraction. So this is a rational number. Now let's go for the square root of 288 over 8. The square root of 288 over 8. So let's go ahead and find out what that is. Let's find out what 288 divided by 8 is going to give us. 288 divided by 8. 28 divided by 8, we have 3. 3 multiplied by 8, we have 24. Let's subtract. We have 4, bring down 8. So 48 divided by 8 is 6. 6 multiplied by 8 is 48. Let's subtract, we get a 0. So this is the same as the square root of 36, which is going to give us 6. And don't forget that 6 can be written as 6 over 1. So it can be written as a fraction. So this is going to be a rational number. And the square root of negative 4 is considered, it's actually a complex number. It's not even a real number. It's not a real number because you can't put it on the calculator. Let's actually see what that looks like on the calculator. I'm going to pull up my calculator here so that you guys can see what I'm talking about, what I'm referring to. So we have negative 4. Let's get the square root. See that? So that doesn't exist as an actual number. It's an invalid output. So negative square root of any negative number does not exist as an actual number. So that is why your answers are going to be the square root of 49 over 81 and the square root of 288 divided by the square root of 8. So those are going to be your rational numbers here. Now let's go do one more example. I'm going to simplify. So we have x squared plus 6x plus 9. So I'll show you the math behind it. So what you're going to do here is we have a quadratic expression, which is ax squared plus bx plus c. Okay, so now we're going to get the values of a, b, and c. Here, a is equal to 1. We're comparing these two expressions together. B is equal to 6. And then c is equal to 9. Now, when you get to this point, you want to find out, we're going to find out the value of a multiplied by c and the value of b. So a multiplied by c is going to be 1 multiplied by 9, which is going to give us 9. B is equal to 6. Now, what you're going to do next is to find out the factors of 9 that give you a sum of 6. We're looking for the factors of 9 that give you a sum of 6. So we have possible factors. Okay, Esther, you're on the right path, but remember, they have to give you a sum of positive 6. So your 6 here is positive, so you have to pay attention to the signs on your factors. So your factors of 9 are going to be, we have 1 and 9. We also have 3 and 3. So now you have to make a decision on which one of, are you going to use the positive or the negative for each of these, positive or negative. So we're going to look at 1 plus 9, that's going to be 10, so that doesn't work. 3 plus 3, that's correct. 3 and 3 are going to give you 6. So what you're going to now do here is you're going to have x plus 3. That's for the first 3 here. and then we open up another parenthesis, and it's going to be x plus 3. So you can see here that this is going to give you x plus 3 squared. But there is a simple method which, as you get more used to solving or factoring quadratics, you would see that a squared, or a plus b, you're going to see that a plus b squared is equal to a squared plus 2ab plus b squared. So if we look at this again, you can see that x plus 3 squared is x squared, and then we leave our 3 squared at the end. Then for the middle term right here, we're going to multiply x by 3 and multiply that by 2, which is going to give you 6x. That is simply what this equation is telling you. So I'm going to go back to the previous. I noticed something in the previous question that I think is worth exploring. Why did you guys all select square root of -4 as your rational number? What was it? What was your thought process? I'm actually curious about that. What was your thought process? Why did you select the square root of -4? I wonder if you thought it was a trick question. I'll wait for some responses just to get, I want to get an idea of how you thought about that question. And then we'll do one more puzzle before we call it a day. Okay, Ida, okay, I can understand that. And Esther, you said it looks right. Okay. Why did it look right? I just want to know how you're thinking about this. Ida, okay, I see what you're saying. So you didn't know you had to solve the square root. So whenever you have a number under the square root, the first thing you want to do is try to make sure that you simplify that square root to see if you can come up with either a rational, irrational, or complex number. Aya, why did you select -4? Why did you select -4 as your answer? I want to hear your thoughts. While Ayo is expressing his thoughts, we'll go to our last puzzle and I'll read it, and then we'll talk through it as you all are walking through the last puzzle. Okay, Ida. I understand where you're coming from. Always remember that anytime you have a negative number under the square root sign, you're not going to get a real number. The number doesn't exist in the way we think about it. Okay, I'm going to put the last puzzle here. Which balls should you put in the holes to make 30? Okay. So that's why I put it there. I wanted to make sure that, Ayo, thanks for your response on that. I wanted to just make sure that you guys can see that. And you notice I put the negative outside and the negative inside. I wanted to see which one of them you guys would remember is not going to be a real number. Okay, which balls should you put in the hole to total 30? This one is actually quite interesting. I'll give you a hint as you walk through this. The ball can be in any direction. It doesn't have to be exactly the way it appears on the screen. It can be in any direction. It can be upside down, can be however you want it to be. Do you even think it's possible? Is it actually possible to make 30 out of this? No, you can only use the same number once. You don't think so? Okay. Okay. And you have to use 3 numbers. You can't leave a hole empty. It has to have a ball in it. Wow, Ayo, nice. That's good. That is good. That is good. I like your thinking. Okay, okay. Very good thinking. Let's see if anybody comes up with anything else. Okay, so we have, Ayo says we should have 11 here. We should have 13 here. And then we have take the 9 ball and make it look like a 6. And that should give us 30. So let's see if anyone has a different opinion or a different point of view on this. Good thinking, good thinking. I wasn't sure if anyone would be able to see that. That was good. All right, looks like that's our best answer. So thank you all for your time. Thank you for joining our session today. It was quite interesting. Great participation. Never give up either. Never give up. Keep trying. Always keep trying. If you keep trying, you will get there eventually. Just keep trying. And I want to thank you again for your time. I know there are lots of things you could have been doing this afternoon, and the fact that you came to join us for this hour, it means a lot. And you guys are the ones that make it exciting to do this every week. So don't forget that tomorrow we start our SAT and ACT program for 15 weeks. You're welcome to join us as long as you're past 8th grade. You're welcome to join. We always try to make sure that anyone from 9th grade and above feels at home, feels welcome in those classes. So we'll make sure that you're accommodated and your questions are accommodated. And so enjoy yourself, enjoy the rest of the day. If you have not subscribed to the channel, please subscribe to the channel so that when we have our upcoming sessions, you get notified. And enjoy your weekend, and I look forward to hanging out with you next week. We have something special next week, and I'm actually looking forward to it. It's going to be a very special event, and so look forward to having you guys next week. Hold on. Ida has a question, so I'm going to take your question. I'm going to take your question. Go ahead and ask your question. Take your question, and then we can dismiss our session for today. If you finish your 8th grade, yes, you're a 9th grader. You are a 9th grader. Ida's question is, if you finish your 8th grade, does that mean you are now a 9th grader? Yes, you're a 9th grader. So, so everyone is welcome to, if you're going to 9th grade, already 9th grade, you're welcome to join our SAT, ACT sessions. So look forward to hearing from you. Let your parents know, and feel free to reach out to us. Our website is mathease.com, matheaze.com. Contact us that way, and we'll be glad to work with you. So enjoy your weekend. See you next week. Remain blessed.